I greet you, ladies and gentlemen, even at this time, as I prepare to share with you a video on how to analyze data using SPSS. In my previous installation, I introduced you to basic data analysis using SPSS. Today, I want to advance a bit, and I want us to cover quite a number of issues. My coverage will be a bit fast, but you can slow down the video on YouTube so that you can follow, or you can even repeat the video where you cannot understand. The data analysis will be based on the work file, which summarizes a study which was conducted in Hungary, in Europe, in Central Europe, in 2011. The study was based on a survey that was done in a certain village called Senli. And the crux of the matter was that the researcher or researchers were investigating the expenditure on different types of energy and the other household expenses of the people in that by and large retirement village. So without much wasting of time, I'm going to share with you the work file. So that is the work file. As you can see, it's a work file of a study that was conducted in a place called Senli in Hungary, in Central Europe. And as you can see, by default, when you are opening a saved work file, SPSS opens to the data view. But for you to make sense of the data set that you are actually analyzing, or that you are looking at, or that you want to analyze further, you need to go to the variable view. So I will go to the variable view so that you are able to make sense of this work file in terms of the key variables or attributes of this work file. Basically, when you look at this questionnaire, it had 62 items that it was investigating or interrogating. These items that are captured by the questionnaire or the research instrument were first the name of the interrogator, which is a string variable, and the label is name of the interrogator. I can just open like that so that you are able to see everything clearly. And I can also drag that tab as well. So the first, you realize that when we are naming variables, we normally are advised to choose shorter names, and then the data labels, they can belong like name of interrogator so that they provide us with information. Obviously, you can't have predetermined values where you are supposed to capture the name of the person who was carrying out the survey. And this name is a nominal variable. We go to the next thing that was captured by the research instrument is the date. The date is a date variable. As you can see, there are so many variables. We have got the numeric, we have got the comma designated, we have got the dot designated, which is almost like the comma designated. We have got the scientific notation. We have got the date variable. We have got the dollar variable. We have got custom currency. We have got the string variable. We have got the restricted numeric integer with leading zeros. So, but by and large, when we are carrying out surveys, we normally craft questions or items in a questionnaire which either conform to the numeric or to the date or to the string. Sometimes for studies where issues to do with money are asked, you may have some items with the dollar signs, and then you'll choose the magnitude of whatever you are displaying. From, if you choose that, it means the width is 7. You choose that, the width is 6, the width is 9, the width is 8, the width is 11, the width is 12, the width is 15, the width is 16, the width is 19, and so on, plus 2 decimal places. And then also captured by this research instrument was the date of the beginning of the study, which we can't provide in advance in terms of values. We need to fill in the date. The date when the study was ended, which also can't be provided in advance. And then we've got the, are you the head of the family? We know the question is qualitative, but we quoted it to be numeric for purposes of analysis, with 1 representing yes and 2 representing no. And then gender, we also quoted it as a numeric variable, 1 for male and 2 for female. And then birth is the year of birth, which we can't provide in advance, the year of birth of the respondents. And then education is the highest level of education of the respondents, which was quoted as 0 didn't answer, 1 below 8 classes, 2 8 classes, 3 vocational school, 4 technical school, 5 high school, 6 technicum, 7 college, 8 university, 9 other, 9 doesn't know. And then we have got source of living. That is, what do you do for a living? The source of income. It was quoted as didn't answer, full-time job, CHAR, full-time job and other, pensioner as number 4, works besides pension, dependent, only child care, full-time job besides child care, part-time job besides child care, unemployment benefit, and so on. There are so many options that they captured there. And then marital status, we have single, married, divorced, partner but not married, widow, being 1, 2, 3, 4, 5 respectively. And then we've got children, number of children. Again, they are quoted as quoted the way you see on your screen there. And then minority, 1 for yes, 2 for no, 9 for doesn't know or didn't answer. And then ethnicity, didn't answer, Hungarian, Gypsy, doesn't know. And then religion, didn't answer, does not belong to any religious grouping or denomination. Roman Catholic, Greek Catholic, Armenian Catholic, Reformed Church or Calvinist, Evangelical Lutheran, Orthodox, Greek Orthodox, Jewish, and so on. And then house type. Also, so many house types were specified, with 0 standing for didn't answer, new house, old house, semi-detached, and so on. And then we go all the way to ownership. It was also quoted accordingly. And then flat floor area, number rooms, didn't answer, doesn't know. And then half rooms, number of half rooms, with 0 being didn't answer, and then 9 being doesn't know. And then half rooms with 0 being didn't answer, 9 being doesn't know. And then we have got running water. Is there any running water in the house? Didn't answer being 0, yes, there is, being 1. 2 being no, there isn't. 9 being didn't know or doesn't know. And then is there any bathroom in the house? And then sewage. Is there sewage in the house? Sewage system. 0 being didn't answer. Yes, being 1. No, there isn't, being 2. 9 being doesn't know. And then toilet, is there any toilet? The options are appearing, just like what we saw for the preceding facilities. And then water, is there any water in the house? Electricity, is there any electricity? The responses are basically quoted the same way, or the options are quoted the same way, with 0 being didn't answer, 1 being yes, there is, 2 being no, there isn't, 9 being doesn't know. And then coal heating, with 0 being no, 1 being yes, 9 being doesn't know or didn't know. Wood heating, quoted the same way as the preceding. Oil heating, quoted the same way as the preceding form of energy. And gas, quoted the same way as the preceding form of energy. Solid fuel, quoted the same way as the preceding form of energy. LPG, with 0 being didn't answer, 1 being yes, 2 being no, and then 9 being doesn't know. And then other heating, quoted the same way as the preceding. And then heating, with 0 being nothing, 1 gas, 2 solid fuel, 3 being gas and solid fuel. And then heating being an option of mainly gas, number 2 being solid fuel. And then, do you live insanely? Did you always live insanely? With 0 being didn't answer, 1 being yes, 2 being no, 9 being doesn't know. And then the questionnaire proceeds with these questions asking about, asking the respondents about where they lived, like where did you live before living in Sandy? What was your previous county? How long have you been living in Sandy? Do you like living in Sandy? Do you plan to move from Sandy to another place? The options are just basically the same as for the preceding questions. And then we proceed all the way to expenditure, and then so as you can see, we proceed with all the kind of services like electricity, heating, expenditure on food, expenditure on clothing, expenditure on healthcare, expenditure on debt, expenditure on total expenditure in Hungarian forint, and the number of people living in the household, the age of the head of the household, have debt, average amount of debt, change, how has your income changed in the past 2 years, how, satisfaction, environment, have you heard about environmentalism, renewable energy, have you heard about selective waste collection, do you selectively collect your waste, and then the household clusters. So these are some of the items that were actually captured by this questionnaire. So without much wasting of time, I will show you the data view. What appears as rows here, which were quoted, now appear as columns under the data view. The name of the interrogator, as you can see, the different names of interrogators, they appear in the first column. And then date appears in the second column. Beginning, when did the study start? I mean the research. For instance, the interaction between these two researchers and the first respondent started at 12:30 in the afternoon and ended at 1 o'clock. It took basically 30 minutes. And then the other questions are captured accordingly. And then we go all the way up to, the 222nd respondent, But you realize that there are gaps. We've got that gap at 215, which is 1. And then there must be another gap elsewhere. There's that clear gap at 215. And then there are some items which were not answered for certain questions. As you can see, we have got quite a number of dots. And then the other thing which I need to point out before I start covering the basics of data analysis under SPSS is that if you realize that here we're given numbers. And these numbers are the codes that were offered for the various options. If you want to see the actual options that were given, you go to the value labels themselves. And then you click there, you tick, and then the information will appear accordingly. So you realize that, but basically to just streamline and keep everything into perspective and avoid cluttering the spreadsheet, we normally, as researchers, untick that part with the understanding that we know what is actually displayed. We know what is actually displayed by the questionnaire. So without much wasting of time, ladies and gentlemen, I will proceed to data transformation. And under data transformation, one thing which I need to point out is that you go to transform, and then you go to compute variable. It gives you that window. For instance, we may be interested in transforming the birth and the date of the study variable in such a way that it gives us additional information, like the age of the respondents, for instance, So what we want to calculate, the target variable is age, and this age, it is simply 2011 because the study was carried out in 2011, minus birth. Age is equal to 2011 when the study was carried out minus birth. And then it gives us, that gives us that information. I will take that again. I'll take that again to demonstrate the transformation. We say compute variable H is equal to 2011 minus birth birth being the year of birth, and then we must get so if you check the results are displayed, I think I've repeated twice that information. Yeah, the results are displayed in the last column as a scale variable. The calculation has been done. As you can see, the last column now displays the age. And automatically under the variable view, we now have row number 63 of age, which is a numeric variable. The width is 8, 2 decimal places. You can write additional information like age of respondents. You can just quote it further, and then we obviously don't enter any information, and it's a scale variable. SPSS is able to do that transformation and come up with that scale variable. And then we may also be interested in doing some analysis where we are interested in knowing the proportion of single people. So we'll go to analyze, and then we go to descriptive statistics, frequencies, and then we select marital status. We select marital status. We select marital status. If you click on statistics there, we could also calculate the quartiles, the percentiles, the mean, median, mode, sum, and also those are measures of central tendency, or even the measures of dispersion, the 6 measures of dispersion, which are standard deviation, minimum, maximum, variance, range, and standard error of the mean, or the characteristics of the posterior distribution or measures of the posterior distribution, like skewness and kurtosis. But we choose not to calculate that as yet. So we click continue, and then we click OK. As you can see, we are able to see this table. This is a very critical table. When it comes to this element on marital status, we are told that we managed to, or the researchers managed to obtain 219 valid responses. There were 3 missing responses. In other words, for 3 respondents, that question was completely not answered. So there were 3 missing responses. And then if you check the proportions, you realize that out of the 219 people who gave valid responses, 12 are single, 102 are married, 27 are divorced, 21 have a partnered or have a partner but are not legally married, and then 57 are widowed, giving a total of 219 plus 3 missing. It gives us 222. which was the total number of respondents for this survey. In terms of percentages, looking at just the percentage, including the 3 who are missing, the 12 single constitute 5.4, because when you say 12 over 222, it gives you 5.4. And then 102 divided by 222, it gives you 45.9, and so on, up to the widowed 57 over 222, which gives you 25.7. When you add these percentages from the single to the widowed, it gives you 98.6 plus 1.4 for the 3 missing, it gives you 100%. But if we exclude the missing and we consider only the valid responses, in other words, we use the total of 219, the percentage of the single increases to 5.5, because it will be 12 over 219, which gives us 5.47, which when rounded off to the nearest decimal place becomes 5.5. And then 102 over 219 gives us 46.6. And then we move all the way to the widows, which is 57 over 219, which gives us 26%, and so on. And then this information is displayed in that pie chart. As you can see, there is a pie chart which shows that the majority of the people in this village called Sandy are actually married. They are actually married. The majority are actually married. The majority in this village are actually married. The single are actually a minority. They are the smallest group. And then the widowed are the next largest group after the married. And then the partner but not married, not legally married, is that Natchez color. And then the green are the widowed. And then we can close that output window. And then we go to analyze, descriptive, statistics, frequencies. But now we want to calculate those other statistics, which I said we may not calculate. We now want to calculate basically everything, so that we can just say 1 or 2 things on all of these calculations. So you can't calculate quartiles and percentiles at the same time. If you calculate percentiles, if you click percentiles, you can't continue, but you can calculate quartiles. And then we click continue, we click OK. If you check, the pie chart is still the same, but we've got a lot of information displayed from which we can just reach some conclusions. The arithmetic mean of marital status is 3.3, is just 3. We want to check in our questionnaire what 3 represents in terms of marital status. What 3 represents, it's divorced. The arithmetic mean is is divorced. We know divorced is closer to married, which is the class with the highest frequency. And then the standard error is 0.091. The median is 2. The median. It means when we look at the first half and the last half of this sample, it's halfway into this sample, you will touch a married person. Demarcating the other half, because 2 represents people who are married, as you can see. So to make sense of the calculations, you have to go back to the original options in the questionnaire. And then here we have got Also the mode is 2, representing the merit. It means the merit have the highest frequency. And then the standard deviation is 1.352. The variance is 1.829. The skewness is positive. So it means marital status is positively skewed. The standard error of skewness is 0.164. And then the kurtosis is negative. It is negative at minus 1.370. And then the range is 4. The maximum is 1. The minimum is 1. The maximum is 5, and so on. And then the other information we've already covered that. So depending on the item that you are analyzing in your questionnaire, it might not be necessarily marital status. It might be something else, maybe more informative, like say total expenditure. It might be something like, say, you may be analyzing something like, say, total expenditure. We take in that total expenditure of households on different things in Hungarian forints. You may be interested in calculating all of these things on total expenditure. And then if you check, the average, the mean expenditure per month in Hungarian forint, it's 99,692.716. The standard error of that figure is 3,828.63 Hungarian forints. And then the median, it means the first half they spend above 85,500, and the second half they spend below 85,500 Hungarian forint. The modal expenditure is 58,500 Hungarian forint. And then the skewness of total expenditure is positive. And then the kurtosis is 1.25, which is below 3. So it means total expenditure is plateautic. It is plateautic. You can easily see this by plotting a histogram with a normality curve, which is what I'm going to do. So we're dealing with the data which is plateautic. We know if the distribution of a variable is flat, like a plateau, we say it is plateautic. If it is more or less like a normal distribution or a student T distribution, we say it is mesochatic. And then if it is, if it has heavy tails and it is pointed like a tall mountain, we say it is leptochatic. So in this particular case, we are dealing with total expenditure, which is plateautic. And then the other things like the range, you can see them from the figures. The range is 332,000 Hungarian forint. The minimum total expenditure being 5,000 Hungarian forint, and the maximum being 337,000. So the household with the highest total expenditure was spending in 2011 337,000 Hungarian forint. And then the percentiles, they also appear with the first quartile, which is the 25th percentile, being 59,875 Hungarian forint. And then the 50th percentile being 85,500, which is our median. we found this figure for the median. If you check, the 50th percentile is the same as the median, and then the 75 percentile, which is the 3/4 percentile, it's 126,700 Hungarian forint. And then we have got multiple modes that exist. Only the smallest is shown. That's the note that appears under the table. And then the rest of the things are displayed accordingly in that pie chart. It's a very complicated pie chart because basically it tried to represent information for everyone in our survey, And then we can close that output window. We analyze. We analyze descriptive statistics frequencies, total expenditure. We want to check in terms of charts. We want the histogram with a normality curve. I say it is plasticatic. I want to show that it is plasticatic. It's more or less plasticatic, as you can see. It's not really picket, but it's more or less plasticatic because much of the distribution is just low with just 2 high peaks there. So on average, the distribution is plasticatic in terms of the calculation, which is why we got a kurtosis of just above 1. It was 1 point something. And then I can close that output window. And then as a student interested in analysis, we can do quite a number of things. Like we go to bar, we go to simple, paragraphs. We click on percentage number of cases. We category axis. We choose, say, gender. And then we choose, say, gender. And then we check what will take place. If we click OK, as you can see, when we click OK, we are able to see that the males, there are more than the females in this survey, with the males between 50% and 60%, and the females being below the males. And then we can also go to graphs, look at dialogues, simple, define. We can also have options. We can have those options. Continue. Have those options. We can have number of cases. Click OK. It gives us another graph, which instead of percentages is now giving us the number of cases. So the more than 120 males and slightly below 100 females. We can calculate the percentages. on your own, ladies and gentlemen. You can calculate the percentages on your own. And then we can also come up with, we can also attempt to, let me close that output window. We can also go to graphs. We go to legacy dialogues. We go to bar graphs. We go to stacked. We go to define, and then we define the category axis will be the highest level of education. The highest level of education, and the definition will be the gender. You can have gender being the definition, and then we have percentage. There you can have number of cases if you want. You click OK. So if you check, you realize that now it has tagged what is being analyzed is the highest level of education. Below 8 classes, you have got almost an equal number of men as women. And then 8 classes, you have got more women than men. And then vocational school, you have got more men represented by the blue than the female, and so on, up to other, which is just comprising of the female. So you can have such stacked graphs as well. You can have stacked graphs. In a future video, I'm going to show how you can relabel a graph which has been calculated by SPSS, how you can relabel it so that you can export a properly labeled diagram to Microsoft Word or to Microsoft Excel, whatever the case may be, whatever the case may be. So I close that output window, We can also create a scatter plot of average income and total expenditure of households. If we set markers by the type of heating, So we go to graphs, ladies and gentlemen. We go to legacy dialogues. We go to scatter dot. We click, and then in scatter dot, we want to do a simple scatter plot. And then we have to define the y-axis. It will be total expenditure in Hungarian forint. It will be total expenditure in Hungarian forint. And then the x-axis, it will be average income. It will be average income in Hungarian forint. And then the markers, we have got the gas or solid fuel, which is heating or pin, gas or solid fuel, and then label cases by, we just leave that at default, and then we click OK. So we have a scatter plot, as you can see, where we are mapping total expenditure against average income. And the marker is mainly gas, mainly solid fuel. You can check at an income of 100,000 Hungarian forint, or below an income of 200,000 Hungarian forint, basically everyone would be spending on gas and solid fuel. And the total expenditure, it varies as well. You can readily see that, ladies and gentlemen. You can readily see that, ladies and gentlemen. You can also do what is known as a box plot. I'm trying by all means to cover much of descriptive analysis. For a box plot, you go to graphs, legacy dialogues, and then you go to box plot. We must look for the box plot. And then the one which we are interested in is the simple box plot. And then it's the simple box plot. And then under the simple, we click summarize. We check that summarize or summaries of separate variables. Summaries of separate variables. And then it gives us that box plot chart edit, where the chart editor wants us to choose the variable. It might be total expenditure, for instance. It might be, it represents total expenditure. We can even take average expenditure, ladies and gentlemen. And then we just click OK. As you can see, things are now grayed out there. We click OK there. You realize that the box plot has come up. It's average expenditure on clothes in Hungarian forint. And your box plot is showing you that we have got much of your average expenditure falling around 10,000 Hungarian forint, all other things being equal. How about the box plot of total expenditure? Of the average expenditure on clothing, it's 10,000 Hungarian forint. How about for total expenditure? Just total expenditure on everything. The box plot for total expenditure. It's graphs, legacy dialogues, and then box plot. Simple, and then we summarize. Summaries of separate variables we define. It's now total expenditure that we're interested in of everything. And then we click OK. Our box plot shows us that total expenditure is just below, it hovers around 100,000, which is what we saw, that the average was 99,000. It was in excess of 99,000. It was in excess of 99,000. The box plot can also be defined in terms of household clusters. You can define your box plot in terms of total expenditure characterized by the type of heating, total expenditure. So I go to graphs, legacy dialogues, box plot, simple. I go to simple. We just experiment with that for the time being. We take that out. We put in fact, I wasn't supposed to take that out. And then we need to choose the clustered box plot. It's graphs, legacy dialogues, box plot, clustered. We take total expenditure, and then options. Click OK. And then we have a gas or solid fuel, gas or solid fuel, gas or solid fuel. We fit it in there. And then we have household clusters, which is second from last there. And then we have household clusters, gas or solid fuel, and then things are grayed out at the present moment. So we're defining total expenditure. The category X is gas or solid fuel. Label cases define. We do that. I do that. And then just check the options and then go to graphs, legacy, then look at the box plot. We check the simple one for what we want to display. And then we go to gas or solid fuel. And then label cases bar, we just rows, columns. Let me just leave it at that and then click OK. The box plot will be like that in this particular case. And then the measures of central tendency and the measures of dispersion, I've already calculated those, ladies and gentlemen. Before I conclude this lecture, I want to just briefly introduce you to hypothesis testing, which I'm going to cover in a subsequent video. And with hypothesis testing, I will start by covering the bit on the setting of confidence intervals. And we'll start with the 95% confidence interval of, say, we analyze, we go to compare means, and then we do the one sample T test. And then we look at a variable like, say, average income. We check the options. It's indeed the 95% confidence interval. The test value, we leave it at 0. We click OK because we want to just check the 95% confidence interval of average income. It's the lower bound is 109,428.41 Hungarian forints, and the upper bound is 127,996.57 Hungarian forint. And then we can also do the same for the 95% confidence interval of, say, total expenditure. Compare means one sample T test. And then this time around, we are looking at just total expenditure. We click OK. The lowest level or the lower bound of total expenditure is 92,147.4136 Hungarian forint, and the highest, the upper bound is 107,238,000.02 Hungarian forint. That's our 95% confidence interval. And the T statistic is statistically significant as well. And then we'll just do 1 or 2 hypothesis tests. And then I will do a video on hypothesis testing. Let us assume one hypothesizes that total expenditure is 150,000. We saw the 95% confidence interval. Clearly 150,000 is beyond the upper bound, but we just want to check. We click OK. So when the test value is 150,000 Hungarian forint, which is way beyond the upper bound of the 95% confidence interval, we discover that the student T statistic is minus 13.14, and the degrees of freedom are 221, which is n minus 1, our n being 222 minus 1, giving us 221. And then the tail distribution for a two-tailed test, the tail probability for a two-tailed test in our critical regions, that is 0.025. We discover that it's lower than 5%. It's actually 0, implying that we reject the null hypothesis that total expenditure is 150,000 Hungarian forint. We reject that hypothesis. It's some other figure within the 95% confidence interval. We know that the 95% confidence interval was ranging from around 92,000 to around 107,000. Let us test with a test value of 102,000. With a test value of 102,000, we go to analyze, compare one samples t-test, and then instead of 150, we put a number which is within the 95% confidence interval that we had initially. We click OK there. Now, it's interesting because 102,000 Hungarian forint is between 92,000 and 107,000, which we had obtained earlier as the 95% confidence interval. We discover that the student T statistic is minus 0.603. The degrees of freedom are still the same at 221, but the probability value is now 54.7% or 0.547, which is higher than 5%. This implies that we failed to reject the null hypothesis that the total expenditure is 102,000 Hungarian forint. So in other words, we accept the null hypothesis and conclude that it's indeed true that the total expenditure is 102,000 Hungarian forint. And again, we saw that it's within the 95% confidence interval. So in a video that I'm going to do next during the course of this week, I'm going to do more hypothesis testing. We'll do Levin's hypothesis test of equal variances, which also gives us test results for equality of means, and as well as other hypothesis tests. So thank you so much for joining in. I believe that you benefited from what I covered today. Remember to subscribe to my YouTube channel and also share my video with your colleagues and encourage them to subscribe to my YouTube channel, as I will be dropping in a lot of videos on how to analyze data using SPSS, which will assist you and your colleagues in your researches. Remember also to comment on things that you want me to clarify in subsequent videos. I will be willing to consider, given time constraints, attending to your queries, also doing future videos in response to the queries of the people in the comment section. Thank you so much for joining in. Have a nice day.